Here the question is, a charged particle after being accelerated through a potential difference V enters in a uniform magnetic field and moves in a circle of radius r. So they are asking us to find if V is double, then what is the radius of the circle, right? So here charged particle is accelerated through a potential difference of V and enters a uniform magnetic field of V. It moves in a circular path of radius r. So let us write the radius of the path r, which is equal to mv divided by q into v. And this m is mass of the particle and v is velocity and q is charge of the particle and v is magnetic field strength. So velocity v of the particle is related to the potential difference v by the kinetic energy gained. So we can write half into mv square, which is equal to q into v. So solving for v, we get v equal to square root of 2qv divided by m. So if you substitute this in r, we get the new radius r dash, which is equal to m divided by dq into square root of 2qv dash divided by m. So here v dash is nothing but double, right? V is doubled. So we are going to write m divided by dq into square root of 2q into 2v divided by m. So finally we get r dash equal to root 2 times of r. So from this we can say that the potential difference is double. The radius of the circular path will be root 2 times of the radius. So answer is option B, root 2 times of radius, root 2 r.